Today we'll be going through lesson 5.5 trigonometric equations, and we'll do day 1. Today we are going to focus on finding the solutions of a trigonometric equation. That's what we will focus on today. So to think about that, we'll first look at sine. And we're going to find the solutions to the equation, the sine of theta being equal to 1/2. So here we have the graph of the sine of x, y equals the sine of x. And what this is asking, it's asking us what angles will produce the y value of 1/2. So what x values will produce the y values of 1/2. So if we draw a a horizontal line at y equals 1/2, that is this line right here, it'll show us where sine is equal to 1/2 at the intersection points. So if we notice, we have points at -7 pi over 6, pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6, and we can keep going. So since this is where we hit 1/2 on our sine graph, that is where we will have our solutions. Now we could name an infinite amount of solutions, but today we are going to be focusing on focusing on solutions that are between 0 and 2 pi. So for our first example, we're going to solve for x, where x is between 0 and 2 pi. So between 0 and 2 pi. And for this lesson, you're going to need your unit circle a lot, so make sure you have that out. So let's take a look at this equation. We have 3 times the sine of x equal to √3 plus the sine of x. Now, to make things a little easier on ourselves, we're going to let u be equal to sine of x. So all that it's going to do is just going to let us work with this equation a little better without writing out sine of x the whole time. And we're just going to be treating this like a normal equation. So anywhere I see a sine of x, I'm going to put a u. So I will have 3 times u equal to √3 plus u. So now I just need to solve this equation for u. So I have to get all my u's on one side, so I will subtract u from both sides, and I will get 2u equal to √3. Now just divide by 2 on both sides, and I will get u is equal to √3 over 2. Now remember, u was sine of x, so we have the sine of x being equal to the square root of 3 over 2. So what this is asking here is what angles produce √3 over 2. So we'll go to our unit circle, look in the y values for positive √3 over 2. And you'll notice that we will have y values of √3 over 2 at 2 pi over 3. So at x equals 2 pi over 3 and pi over 3. And since we are focusing on the angles between 0 and 2 pi, those are the only two we need. So our final solution is x equals 2 pi over 3 and pi over 3. Now for our next example, we are getting a solve for x for whenever x is between 0 and 2 pi. So we're only going to worry about those angles. And our equation is 3 times the sine of x minus 2 minus 5 times the sine of x minus 1. Again, to make things easy on us, for solve this equation, we're going to say that u is equal to the sine of x. And all that is, that's just to help us out solving the equation, making it easy on ourselves. So I have a sine x here and a sine of x here. So anywhere I see those, I'm going to put a u. So I will have 3u minus 2 equal to 5u minus 1. So now you just need to solve for u. I would like to keep my variable coefficients positive, so I'm going to subtract 3u from both sides. It doesn't matter, you could have subtracted 5u. I just prefer to do the 3u. These 3u's cancel out. So I have -2 is equal to 5u minus 1. Add 1 to both sides, I get negative 1 is equal to, I'm sorry, not 5u. This will be a 2u. So we have negative 2 equals 2u minus 1. Add 1, I have negative 1 is equal to 2u. And then u will be equal to negative 1 half. And remembering that u is equal to the sine of x, so we have the sine of x being equal to negative 1 half. So we need to find out what angles produce negative 1 half. So if we look at our unit circle looking for negative 1 half in the y position, and we have negative 1 half in the y position at 7 pi over 6. And we also have negative 1 half and the y position at 11 pi over 6. So our final solution is x equals 7 pi over 6 and 11 pi over 6. Our next example is we are again solving for x whenever it is between 0 and 2 pi. And this time our equation is 2 times the sine of x over 2. And notice this is the sine of x over 2, not sine times x over 2. And we're going to find out when that is equal to 1. So to do that, I need to get sine of x over 2 equal to 1. If you would like to, again, you can let u equal the sine of x over 2 this time. So we're going to let u equal the sine of x over 2. You don't have to for this one. It's not as difficult as the equation to solve, but if it helps you out, go ahead and do it. So we have 2 times u being equal to 1. Divide 2 by both sides, so u is equal to 1 half. So we are looking for when the sine of x over 2 is equal to 1 half. So to figure this out, to find out whenever the sine of x over 2 is equal to 1 half, let's just look at plain old sine. So let's find out whenever sine of theta, just plain old sine, is equal to 1 half. So we'll go to our unit circle, find out where we have an x value of 1 half, and that is at pi over 6 and 5 pi over 6. So we know that the sine of theta is equal to 1 half whenever theta is equal to pi over 6 and 5 pi over 6. So we know that in order for the sine of x over 2 to be equal to 1 half, this x over 2 needs to be equal to pi over 6 and 5 pi over 6, because if you take the sine of pi over 6, you get 1 half, and you take the sine of 5 pi over 6, you will also get 1 half. So what we're going to do is we're going to set x over 2 equal to pi over 6 and x over 2 equal to 5 pi over 6. And then we'll solve both of these for x. The first one is multiply by 2 on both sides. You will get x is equal to pi over 3. Bottom one, again, multiply by 2 on both sides, and you'll get x is equal to 5 pi over 3. So our final solutions are x equals pi over 3 and x is equal to 5 pi over 3. So both these last two examples, this example is like the problems numbers 11 through 24 on your homework. And then again, this problem is the same. It's like numbers 11 through 24 on your homework. So if you're having trouble on your homework, go ahead and look at these two examples, and then they'll be able to help you out. So now let's look at the next one. We're we're solving for x when it is between 0 and 2 pi again. And this time our equation is sine of x plus cosine is equal to 0. So we have to figure out what values we can put in for x in both sine and cosine that will give us 0. So let's do some rearranging with this equation. If we subtract cosine from both sides, we will have the sine of x being equal to the negative cosine of x. So what this is asking is, when is the sine of x equal to the negative cosine of x? And to figure that out, we just need to look for when the sine of x and cosine of x are the same values. So we look at our unit circle and find out whenever the x and y values are the same, except we just need to look at where the signs are opposite. So if you notice at 3 pi over 4, cosine is equal to negative root 2 over 2, and sine is root 2 over 2. Well, since they are the same number but with different signs, we know that x equals 3 pi over 4 will be a solution. And we'll go around the rest of our unit circle and look for the same thing when the x values and the y values are the same but to have different signs. And if you look, you'll notice at 7 pi over 4 we will have the same thing. At 7 pi over 4, cosine is equal to root 2 over 2, but sine is negative root 2 over 2. So they're the same number with different signs, so that will also be a solution to this problem. So those are our two solutions. And again, this is like problems 11 through 24 on your homework. So I would like for you to do this one by yourself. You're going to solve for x when it is between 0 and 2 pi. So only the angle is between 0 and 2 pi. For the equation, sine of x times tangent of x is equal to sine of x. And a little clue to get you started is to solve this equation for tangent of x. So go ahead, pause the video, and work this out, and then unpause it whenever you are ready. So here's the solution to this problem, and tangent, or the sine of x times the tangent of x will be equal to sine of x whenever x is equal to pi over 4 and 5 pi over 4. For this next example, we're going to use substitution to determine whether the given x value is a solution to the equation cosine of x equal to root 2 over 2. And we're going to substitute pi over 4 into cosine and see if we get root 2 over 2. So I'm looking at the cosine of pi over 4. Sorry about that. Well, let's check our unit circle. Go to pi over 4 and look at the y value. And the cosine of pi over 4 is equal to root 2 over 2. Since that was what the equation asked, we determined that the cosine of pi over 4 is equal to root 2 over 2, so this will work. So go ahead, work through these two team huddles. Do this by yourself, so go ahead, pause the video, and see if these will work. So here are the solutions to these two problems. For the first one, it is not a solution, and the second one will work, so it is a solution. So that finishes up today's lesson, and here's your homework. It's page 636, numbers 3 through 24, multiples of 3, and for numbers 11 through 24, numbers 11 through 24. You are only going to find the solutions for whenever x is between 0 and 2 pi. it says to find all solutions, but I just want you to find the ones between 0 and 2 pi. Okay, good luck.